Slide number 67. With this, we have come to the first of our cycle clutch adjustments, namely that of the lateral position of the cycle clutch spring. Notice the gap, or the space, which exists between the right edge of the cycle clutch spring and the shoulder of the pulley hub. This clearance should be reduced to 1/4 of 1 millimeter. When the clearance is not there, the pulley hub might interfere with the operation of the cycle clutch spring. Any excess gap, on the other hand, will cut down on the number of coils of the cycle clutch spring which can be engaged with a driving arbor. The end result would be a reduced life for the cycle clutch spring. Slide number 68. In order to make it possible to position the spring sideways, it is necessary to first loosen the clamp and then to open or expand the diameter of the spring. The diameter of the spring can only be expanded if we hold both ends of the spring and build up pressure between them. After rotating the cycle shaft into the convenient position shown here, we use 2 screwdrivers and place the spring sideways into the desired position. Keep an eye on the scribe mark in the left end of the spring. After you position the spring laterally, you should have the left lug lined up approximately with the scribe mark. As mentioned, this is only a preliminary setting anyway for the angular position of the spring. Slide number 69. We now have to position the collar and the cycle clutch latch restoring cam, because in our next adjustment we must start out with the clutch spring held in its position, no matter how far off we are. We must therefore learn how to set the preliminary position of the restoring cam and the collar. First, we positioned the opening in the clutch latch restoring cam and the collar around the left end of the clutch spring, green pointer, so that we are slightly off-center, with a larger portion of the opening towards the rear of the machine. Then we positioned the collar in relation to the nylon cam, so that we had equal portions of the nylon cam showing, as indicated by the yellow and the blue pencils. Do not yet tighten the collar. So far, our efforts take care of the preliminary setting of the angular position of the restoring cam and the collar. Now let us go to the lateral positioning of the two. Slide number 70. Before we tighten the collar, we should always position the cycle clutch restoring cam sideways so as to allow for a bit of lateral play for the cycle clutch sleeve at the point indicated by the green pencil. It is very important not to cause any binds for the cycle clutch sleeve, since this could hamper the movement of the spring when it tries to collapse. Now we tighten the clamp. Stop your tape player while you do it, and get ready for the miniature brainstorm when you restart it. After the lateral adjustment of the cycle clutch spring comes the cycle clutch adjustment number 2. Can you remember what it is? Your answer should have been, the second adjustment of the cycle clutch is the angular position of the cycle clutch spring. The angular position of the cycle clutch spring is very important to this mechanism, since it determines by how much the clutch spring is held open. First, let us learn how we determine whether our adjustment is correct or not. We have to introduce a method which allows us to measure or gauge the stress, the distortion, or the amount of opening which we cause the clutch spring to undergo. Consider this. When we cycle a character, the motor will drive the cycle shaft until the exact point at which the clutch disengages. In other words, until the right end of the spring, or until the step or the sleeve stops against the cycle clutch latch and disengages the clutch. When we use the hand cycle wheel instead of the motor, and then hand cycle the operational shaft and the pulley slowly. The cycle shaft will also turn slowly, and the momentum developed by this slow turning will be negligible or almost nil. If, in addition to this, we use a character which places a load onto the cycle shaft during the last portion of the rotation of the shaft, we know for sure that the cycle shaft cannot develop any momentum at all. That is accomplished by our choosing the letter M. Slide number 71. To perform the second adjustment of the cycle shaft, we depress the letter M and then slowly hand cycle the operation until the cycle shaft is no longer driven by the cycle clutch. Another way of saying the same thing is to hand cycle a letter M until the cycle clutch begins to slip. Then we go to the print shaft bearing and make a mark on it. We made ours on the spring which holds the bearing. We then take a good look at the point of the print shaft gear which coincides with the mark. In our example, it is the low portion of the dwell between two teeth of the print shaft gear. We must now place this information in the back of our mind. Let us see whether you can answer this. Where did the print shaft stop when the cycle clutch began to slip? All we have to do is just look at it. When the print shaft stopped, the cycle clutch began to slip. This happened at the point where the lowest point of the space between the teeth, immediately above the tooth indicated by the red pencil, is aligned sideways with a mark which we have made on our print shaft bearing. Now we must check how far this is away from the check pawl position. In other words, now we shall continue to turn the cycle shaft and find out how much further we have to turn it before the check pawl falls into its rest position. But we cannot keep our eyes on the gear and the check pawl at the same time. So we simply place our left finger on the pawl in order to be able to feel when the pawl falls into its position. With our right hand, we depress the letter M once more, and then, very, very slowly, we turn the hand cycle wheel while keeping our eye on the print shaft gear and our finger on the check pawl. In our example, the check pawl fell into place when the indicated gear tooth, the one with the black mark on it, was aligned with a mark on the bearing. This amounts to just slightly more than 1/2 tooth of rotation for the print shaft. The manufacturer's specifications call for anywhere between 1/2 to 1 full tooth of rotation before the check pawl falls into its position. We know therefore that our adjustment is correct. A most interesting question at this point is, what should we do in the event that our adjustment is set incorrectly? Simple. First of all, there are only two possibilities. One, that we disengaged our cycle clutch too early. We determine this fact by finding that the print shaft gear had to turn more than 1 full tooth before the check pawl fell into its position. Can you tell us what we should do in order to correct the problem? Your answer should have been to rotate the cycle clutch spring top to the rear so that it can drive the cycle shaft further before the cycle clutch sleeve meets the cycle clutch latch and disengages the cycle clutch enough so it must begin to slip. The second possibility is that we get less than 1/2 tooth of rotation for the print shaft gear before the check pawl falls into its position. Now the cycle clutch is driving the cycle shaft too far. The corrective measure here is that of rotating the cycle clutch spring top towards the front in order to enable the cycle clutch sleeve to stop against the cycle clutch latch earlier. All the while, we must make sure that the cycle clutch latch restoring cam, or the overthrow stop, is kept rotated top to the rear far enough so as not to interfere with our clutch spring adjustments. Given the right conditions, the overthrow stop cam can cause the jamming of the cycle clutch when it does not allow sufficient rotation for the cycle clutch sleeve. Whenever this happens, we have to manually disengage the cycle clutch latch, correct the position of the overthrow stop, before we can continue with the adjustments of our cycle clutch spring. Now think back for a moment. Let us assume that this operation had been performed by the motor and that we had printed our letter M. The cycle shaft would, of course, have rotated all the way into its check ball position, bringing the left end of the cycle clutch spring with it. The right end of the spring, however, was stopped earlier by the cycle clutch latch. The free spin of the cycle shaft caused the spring to expand. How large was this free spin? If it was more than 1/2 of rotation, the clutch spring ended up being opened too much. If the free spin was less than 1/2 of 1/2, the clutch spring was not opened enough. We are quite confident, to say the least, that it would not hurt you to go through this information again before continuing. Make sure that you stay with it and repeat it until you understand it and until you can honestly say that you know it. The starting point for a repeat session of this portion of our program is slide number 67 and the beginning of side 2 of this audio tape. Which is the third adjustment of the cycle clutch? Slide number 72. It is the lateral position of the cycle clutch latch restoring cam. We take care of that whenever we clamp down the cycle clutch spring. Just always make sure that whenever you tighten the clamp, the cycle clutch sleeve has enough side play so as not to allow any binds to develop. What about the fourth and final adjustment of the cycle clutch? Can you remember what it was? The fourth and last adjustment step of the cycle clutch adjustments is the angular position of the cycle clutch latch restoring cam, or the overthrow stop adjustment for the cycle clutch. There is one extremely important point to remember when making this fourth adjustment of the cycle clutch. Be sure to let the clutch spring collapse before you loosen the clutch clamp. Remember that a spring must be held at both ends in order for it to be possible to build up any tension in it. The moment in which we lose hold of one of the ends, we find that the spring will collapse. Should we ever make the mistake of loosening the cycle clutch clamp when the right end of the spring is being held open by the cycle clutch latch and the left end is being held by the check ball, we will immediately lose the angular position of the cycle clutch spring, and we would have to start again from the beginning with our 4 adjustments of the cycle clutch. If, however, you make it a habit of yours to always and only work on the cycle clutch adjustments when the cycle shaft is rotated into the position shown here, you will always have had to let go of the right end of the cycle clutch spring. And when the spring is collapsed around the arbor, it does not slip and change its position unless you first expand its diameter. It therefore becomes very simple to open the clamp and adjust the angular position and or the lateral position of the cycle clutch restoring cam without disturbing the position of the spring. After we get done with step number 4, we should check steps number 2 and 3 once again, just in case it might need some correcting. Slide number 73. The angular position of the cycle clutch restoring cam, or the cycle clutch overthrow stop, should be adjusted in such a manner that the amount of play between the maximum forward position and the maximum rearward position of the cycle shaft at the indicated point is approximately 1/4 of 1 millimeter. At this point, you should stop your tape player and perform this final adjustment of the cycle clutch. Can you still make a list of the preliminary adjustments of the printing mechanism or the cycle clutch? It should contain the items: cycle clutch latch height adjustment with hooverometer, cycle shaft end play, gear backlash elimination, filter shaft timing, print shaft timing. You might even have included the cycle clutch latch restoring adjustments. These preliminary adjustments place our machine into a condition which allows us to cycle the printing mechanism, and as a result we can turn our attention to the cycle clutch or the print clutch. Can you make a list of the adjustments of the cycle clutch? 1. Lateral position of the cycle clutch spring. 2. Angular position of the cycle clutch spring. 3. Lateral position of the cycle clutch restoring cam. 4. Angular position of the restoring cam. Overthrow adjustment. Upon conclusion of the cycle clutch overthrow adjustment, we make it a point to recheck the adjustment number 2, or the angular position of the cycle clutch spring, for the 1/2 to 1/2 of rotation required before the latching of the check ball. Make whatever corrections are needed on the cycle clutch of your typewriter. Stop your tape player. Slide number 74. Now rotate the cycle shaft top to the front as far as it will go, and then check the position of the filter shaft. The interposers should all be able to come down without touching the cam of the filter shaft. You may refine the position or the timing of the filter shaft at this point if it needs it. Slide number 75. As your last step in this program, be sure to reset all of the key lever restoring springs by placing a screwdriver as shown and then forcing it straight up. We extend our congratulations to you for having finished this first of our series of 5 training segments on the IBM Selectric typewriter. You should review this package often, particularly if you do not work on these machines all the time. You should now continue your studies with package number 10-2A. We thank you for your attention. Please fast forward this audio tape all the way to the end of side 2 before returning it to storage.